Okay, we are live. Hello, everyone. Welcome to another edition of the iOS Lead Essentials podcast. I'm Mike.
And I'm Kaio.
And this week, we're going to reply to some questions about common UI architectural design patterns. MVC, MVVM, and MVP.
That's it? So first question, what is MVC? The oldest one of the patterns. And the one where the other patterns derived from.
Exactly, it's the foundation.
So MVC stands for Model, View, Controller. And it gives you guidelines for separating the concerns in applications with a graphical user interface.
Exactly. It's a way to classify components either as models, as views, or as controllers.
So the model represents the business logic. It represents business data, or even services.
Mm-hmm.
And usually you want the model, the business logic, to be decoupled from views or even controllers, any framework-specific implementations.
Exactly. Because that's what makes it reusable, that's what makes it easily testable, extendable, maintainable, all the good things.
Yeah, because it's completely isolated. And the business logic is the most important part. The part that needs to be 100% right. So, you want it to be tested in isolation in a way that is easy to maintain, extend, and test. So that's the model part. What about the view? The V in MVC, what does it represent?
Okay, the view represents elements that the user can interact with. So, labels, text fields, table views.
Buttons,
exactly. This sort of components. And the views are also decoupled from models and controllers.
Right. Usually, you want the views also to be decoupled from the models and the controllers.
Mm-hmm.
For example, in UIKit, the UI view doesn't know about the UI view controller. The controller knows about the view.
It's the opposite. Exactly.
But in some implementations, you see the view referencing the controller. It's not the traditional way of doing it, but there are so many variations of MVC that you can find those different ways of plugging the components. But usually, the view does not know about the model or the controller.
Right.
And again, you also see implementations where the view knows about the model. You pass the model to the view and the view configures itself.
Right.
So that's fine as well. It's not a traditional way, but you can find such solutions out there. But traditionally, the view is decoupled from the controller and usually from the model as well. So if the model is decoupled from the view and the controller, and the view is usually decoupled from the model and the controller, how do they communicate?
That's the job for the controller.
That's it.
A controller is a kind of mediator that updates the view based on the model state, and it also communicates view events back to the model to update its state if necessary.
Right. For example, if a user taps a button on the view, the controller can receive that event, the view event, translate it to some model command, and tell the model to perform some business logic.
Yes.
So that's the traditional way of separating the concerns.
Exactly.
But of course, you can create some variations here and there to solve your challenge at hand. It's not that restrict. MVC is so flexible that other patterns arrived out of it, right? You have the initial guidelines, but you can adapt it.
Exactly. But as you said in the beginning, that's the foundation.
Yeah.
It's this classification of components into separate types that are decoupled, or there is a specific type of object that mediates or couples some of them. So you get this very nice separation of concerns, this pluggable UI architecture, if you like.
Yes. And there's nothing talking about network connections or databases in the MVC pattern, right?
No.
MVC is just about the graphical user interface, how to plug the models with the user interface. And that's it. You need other patterns to deal with networking, databases, and etc. And one of the biggest misconceptions of MVC is that every screen has one model, one view, and one controller.
Right. Yes, absolutely. This is so important because this is basically the premise for ending up with MVC, where M stands for massive. So if you get all the responsibilities into one controller, for example, one view controller in UIKit, then you're going to end up with an inflated class that does too much, and it's going to be very hard to maintain and test.
Not just the controller, but the view can get a lot of responsibilities as well.
Mm-hmm.
The model representing one single screen can get a lot of responsibilities as well. So that's a misconception. In MVC, it's not one model, one view, one controller. One screen can have dozens, hundreds, tiny MVCs. You compose a bunch of MVCs to create one screen.
Exactly. It's not only possible, it is also advisable to separate your screen into many MVCs.
Exactly. You could have like one MVC to control exactly one button, another MVC to control a cell.
Exactly.
And so on. And if you're using MVVM, again, it's not one ViewModel, and one view. A screen can be composed of multiple tiny MVVM components. And MVP, the same. It's not one. All right. Next question. What is MVVM? So, MVVM is a variation of MVC. So it's also an architectural UI design pattern.
Yes.
So in MVC, you have model, view, controller. In MVVM, you have model, view, and ViewModel. So what is missing there? The C.
Exactly.
So you don't have a controller. You don't have this mediator as you had in MVC. You have a ViewModel. And the difference is that in MVVM, the ViewModel that replaced the controller does not reference the view directly. In MVC, the controller usually references the view directly.
I mean, in UIKit, it is baked in the Apple MVC because the UI view controller has a strong reference to the UI view.
Yes. But in MVVM, the view model ideally should not reference the view. It's either the view referencing the view model to configure itself, or having another component to bind them.
Right.
The binder object. That's why MVVM is also called Model View Binder. So MVVM was created by Microsoft.
Right.
Exactly to eliminate the boilerplate they find in controllers, configuring the view with the model, passing the events from the view to the model, from the model to the view, etc. They noticed that there is a lot of duplication in there. If we could find a mechanism that binds the view with the model easily, we could eliminate that. And thus, MVVM was born. So, in MVVM, the model is the same model as in MVC. It's the business logic. But you don't want to plug the view directly with the model.
Right.
Otherwise, the model will start doing view logic. So you want something in the middle to translate the model for the user interface. That's the view model. And to bind the view model with the view, you need a binder. In Microsoft, you can use XAML to define the binding. For example, so you define your view structure in XAML and the binding with the view model. And the framework does all the magic for you. But we don't have this in UIKit.
No, we don't.
So we need to use a framework for binding the view and the view model, something like RX Swift or Combine.
Right.
But you don't need a framework.
Right.
You can create your own bindings. You can use simple closures to bind the view and the view model.
Yeah, and usually this happens through the view controller.
Yes. Since you need a view controller in UIKit, usually the view controller gets the responsibility of binding, so it's the binder between the view model and the view. But in Swift UI, you have the property wrappers, at state and at observable object, which could be view models binding directly with the Swift UI view and the observable model. So every time there's a change in state of the view model, the view re-renders itself.
Mm-hmm. It reacts to the state change.
Yes. So that's it. The goal with MVVM is to remove boilerplate code by having some automatic way of binding the view with the view model.
Mm-hmm.
And all translation logic goes to the view model, the presentation logic.
Right.
Like if you have a date object in your model, you translate it to a presentable string for the view. So the view can just render a presentable string. All the formatting logic stays in the view model.
So this is a formatting layer before the data reach the views.
Yes.
Right. And this is important because it can make your apps, it can make your code bases platform agnostic, or at least this business logic with the presentation, the formatting that we're talking about right now, because they have no reference to the UI, to the delivery mechanism part of the application.
Yes. For example, if you're following MVC and you have some formatting logic in your controller, let's say your UI view controller, you cannot reuse that in another platform that doesn't support UIKit.
Right.
For example, you cannot use it on a macOS application. You have to duplicate the logic. But if you move it to a platform agnostic view model, you can reuse the view model in any platform as long as it doesn't reference any UIKit element or any other platform-specific framework. But that's a choice.
Exactly.
Because you can also create your view models coupled with the view framework. For example, if you reference UI color in your view model or UI image, then you're coupling your view model with UIKit, the view framework. And that's fine if you're just releasing iOS apps, but you lose some benefits of reusability in other frameworks and also testability without the simulator.
Yes.
So it's a choice. It's up to you to decide. Next question. What is MVP? And how is it different from MVC and MVVM? So, MVP stands for Model View Presenter. So MVC, Model View Controller. MVVM, Model View ViewModel. So the model and the view exist in all of them.
Yes.
The only thing that changes is the controller, view model, and now the presenter.
It's this intermediate binding mechanism, right? That has a different set of rules, basically.
Always the mediator between the view and the model.
Yes. In all three cases, we see the model and the view, they don't know about each other. They are separated, right?
Yes.
There is this intermediate layer.
It doesn't have to be separated, but you usually want a separation.
Yes.
Because if your views reference the model directly, very soon you're going to start adding logic to your models specific to the view.
Right.
Just because it's convenient.
Yes.
And if your model references the view directly, you're coupling your business rules with a UI detail. So if you need to change the UI, you may break the business logic, which should be completely decoupled because there are multiple ways of presenting and rendering your business rules. So, MVP. What is MVP? Model, View, Presenter. The model is the same model as MVC and MVVM. It represents the business logic, the business data. The view represents the user interface that the user, the customer, can interact with. Now, the presenter is responsible for translating, transforming, or formatting the model data into presentable models for the view. Similar to ViewModels, it translates the models in a presentable way for the user interface. So formatting logic can go to the presenters. And the presenter has a reference to the view. Just like in MVC, where the controller references the view, the presenter also references the view. But not directly to the concrete view. For example, a presenter should not reference a UI view, the concrete UI view class. It references an abstraction. For example, a protocol. So the presenter is not coupled with view frameworks. The view frameworks should implement the presenter view protocol abstraction.
And that makes it platform agnostic because the view boundary is separated with the rest of the application.
And you can achieve the same with MVC. You can create an abstraction in between your controller and your view.
Yes.
But that's not the traditional way of doing it. In MVP, that's the guideline. You should have an abstraction representing the view, and the view protocol, the view abstraction, belongs to the presenter. So the UI needs to implement the presenter view. So you have the dependency inversion principle applied there. Instead of the presenter depending on the UI, you invert the dependency. The UI depends on the presenter, which makes it much more testable, reusable. For example, if you have a UI kit view implementing the presenter view, and you want to use Swift UI now, you just make your Swift UI view implement the presenter protocol, you replace it, and you don't need to change anything in the presenter side or in the business logic side.
Yes. That's the power of the boundary between the UI and the rest of the application. That's exactly right. It's very powerful.
You don't need exactly a view implementing the presenter view protocol. In UIKit, the view controller could implement that protocol and represent the view. So it's very flexible as well, MVP. You can achieve the same level of separation with MVVM or MVC.
Yes.
It derives from MVC. Right? So if you're creating an MVC solution and you need this level of separation and you start creating abstractions, you're going to end up with MVP.
Yes.
Now, if you have MVP and you want to simplify some object communication because you don't need this level of abstraction, you're going to end up with MVC. You can refactor from one to the other very, very easily.
Yes.
And the same with MVVM. It all depends on your goals.
And one last note I would like to add here. There's a difference in MVP and MVVM where both patterns use the term ViewModel. In MVVM, the ViewModel component holds data and behavior.
Right.
That means it coordinates the state of the system that the view needs to react to.
Yes, it has even dependencies. Right? It's common to see a view model with a service.
Exactly.
And the view model is responsible for managing those dependencies and translating the state in a presentable way for the view. So in MVVM, a view model usually has behavior and dependencies.
Yes. But in MVP, a view model usually represents immutable data, represents the model the views will need.
Right. So that's why in MVP, a view model is usually represented by a immutable struct. It doesn't need any dependencies. It just has properties, for example, just presentable strings that a view can consume and render on the screen.
Yes.
So, not to confuse the view model from MVVM with view models from MVP or even MVC, usually people call view models in MVP just presentable models. So you have the model and the presentable model.
Exactly.
So it depends. Some teams also decide to create MVVM where the view model is just data. But in MVP, the view model never has behavior. It's only data. In MVVM, it's pretty much a choice depending on the problem at hand. You can mix both. Some view models only represent data, and some other have some behavior. But it's up to you to decide. In MVC and MVP, a view model is a presentable model that only holds data. In MVVM, a view model can have behavior and dependencies. Next question. Which UI design pattern is best? MVC, MVVM, or MVP? Classic question.
Yep.
Just tell me the best one so I don't waste my time with the other.
Yes. Well, there is no best design pattern. There is no silver bullet. As we often say, it depends. It depends on the challenge at hand. It depends on the team skills, the collective knowledge. It depends on many factors, actually.
Yes. So, no, there is no best design pattern. They are all good design patterns. They help you create a good separation of concerns between your user interface and the business logic. That's it. And you can tailor your solutions to your problem. Sometimes you start with MVC. You need a little bit more abstraction in between your controller and the view. You're going to end up with MVP. If you want to eliminate some boilerplate code, you might end up with MVVM.
That's exactly right. And it is easy to change, or rather it should be easy to change. If you achieve the separation of concerns, then it should be easy to shift from MVC to MVP, for example, or even the opposite.
Yes, but consistency is important. So changing from one to the other can be costly if you have a huge code base.
Yes.
And you want to change the whole code base to a new pattern.
Yes.
Maybe that's not the solution.
And that is the reason why you need to break down things as well. Because if you have just one controller for coordinating, like a whole set of behaviors on the screen.
Let's say 3,000 lines of code.
Yes.
In one controller.
3,000 lines of code. That would be a nightmare to work with. That would be a nightmare to change.
Yes. And the solution to that is not MVVM or MVP. The solution is to break the view controller into many tiny MVCs.
Yes.
And compose them. So any of those patterns are going to help you create flexible, testable, and maintainable user interfaces. But all of them can also give the opposite if they're not breaking down into modular tiny components. So you need to balance your challenges, the deadlines, and the maintainability of your code base. And if you're using UIKit, you already get by default an MVC implementation. So you're going to have your controller, your view, and probably your model. But UIKit's flexible enough that you can go and use your own design pattern there. So maybe you're going to decide to go with MVVM because that's the one you're most comfortable with, and the team is also most comfortable with that. That's fine. Or maybe you're going to say, no, I prefer MVC because I'm more comfortable and more used to it. That's fine as well. Or you might decide to go with MVP. So it's a team choice. All of them are fine. And there are other patterns as well. There's not only these 3 patterns. There are many others. As long as you have the skills to achieve the goals, a clean separation of concerns, a maintainable, extendable, and testable architecture, that's it.
These are the goals. That's exactly right.
The goal is not to implement MVC, MVVM, or MVP.
No.
The goal is to achieve this maintainability, extendability, testability.
These design patterns are simply a tool that they're going to help you manage your code to solve a business problem, right?
Yes.
We should not be married to the design patterns. We should use them smartly for solving our problems.
That's it. Next question. What is the best design pattern for creating reusable components? So you can achieve reusability with any of them.
Yes.
As long as you create the good abstractions in between your components, they are reusable.
Yes.
But out of the box, just following the guidelines by the book, they have different levels of reusability. For example, MVC, the view controller, is coupled with the view, with the concrete view.
Right.
So you cannot reuse the controller with another view, for example. That's why usually you say that controllers are not reusable.
Right.
That doesn't mean you cannot put an abstraction in between and make that controller reusable. But if you do so, you end up with MVP, most probably. Your controller becomes kind of a presenter.
Yes.
So we can say that MVP is more reusable than MVC.
I'd say, yeah.
The same with MVVM, where the view model can either be coupled with the view framework or can be framework agnostic.
Right.
If it is framework agnostic, it's more reusable in different platforms, in different contexts, different views. Thus, you can say that MVVM is more reusable than MVC as well. But nothing stops you from making MVC more reusable.
Exactly. The problem I find with MVC is that the controller and the view are coupled together.
Well, the controller is coupled with the view.
Yes. So, for example, in MVC, the controller will import UIKit by default.
Yes, the UI view controller is a UI kit element. So
Exactly.
yes, it depends on UI kit.
Yes. So it belongs in the UI.
Right. But nothing stops you from creating your own controller that doesn't inherit from UI view controller.
That's very true. Yes, of course. But let's shift to MVVM here for a second. If you were to import UIKit in MVVM in a ViewModel component, then your ViewModel would be coupled with a UI.
Yes.
Right?
And you might have to do so if you have UI image or UI color references in your ViewModel.
Yes, that's exactly right. And as you said before, if this is what you need and you don't care about multiple platforms,
reusability or something like that. Yeah.
Yes, then that's definitely the way to go. If you do care though, you'll have to be careful and decouple the UI part. So all the UI images should be some sort of a generic version of an image, or the colors, right? All these things should be platform specific.
So if you create a generic representation of an image, for example, we can reuse the same view model, but when we compose it in a specific platform, we use, for example, UI image in UI kit. We can use NS image in macOS or WK image in the watchOS.
Yes, exactly.
But the same view model.
With the same view model, yes. I mean, it's pretty, it's fascinating. If you want this level of separation, you can do it, and it worked great, right? Again, it's not for all cases.
So you can achieve reusability with all of those patterns.
Yes.
It's a choice. But some patterns already gives you out of the box this reusability. So let's rank them. If you get out of the box, least reusable, MVC, MVVM, MVP.
I agree. I agree with that. Yes.
But very close, MVVM and MVP. I don't know how to order them. Maybe the same side. So MVC is the least reusable out of the box, but you can tweak it to make it reusable.
Yes.
All right. And maybe, does it even make sense to make a controller reusable? In some cases, probably. Who knows?
Perhaps. Let's just say perhaps.
Next question. A lot of job postings require MVVM skills. True? Should I learn only MVVM or all UI design patterns? So the market is requiring MVVM skills. Should I just learn what they're asking? Well, if you want just to get a job, sure. If you apply for a job that requires MVVM, you need to know at least MVVM.
Yes.
But that's a finite mindset. Like getting a job is a finite goal. I got it. That's it. I'm set for life. That's not how your career works. Your career is a marathon, not a short sprint.
Yes.
Right? It's infinite. So if you're playing the infinite game, if you want to achieve a remarkable career in the short and long term, I believe you should learn the foundation of all the principles and practice. Learn how they relate, how they are similar and how they are different.
Yes.
How to refactor from one to the other. How to make all of them testable, reusable, extendable, maintainable.
So the problem with these patterns in the workplace is that probably every other team has a slightly different implementation of MVVM.
Completely different
or completely different implementation, yes. So, you can be in a team and you are using one version of MVVM, and then you go to another team and it's just like it has no resemblance with what you already know.
Yes.
So you need to learn the new methodology. But I think what you said before is the most important of all. Getting the fundamentals right? The foundation, which is achieve clean separation of concerns, classify the objects and contain them into their types, have good communication between components and layers. These are the things that are going to allow you to work with any version of MVVM or MVP or whatever design pattern you're using.
Exactly. Because the goal is not to use the pattern. The goal is to achieve flexibility, maintainability, extendability, testability, and etc. That's the goal. The pattern is just a tool to get there. Whatever pattern the team is using, you should be able to understand how it helps achieve the goal.
Yes.
If you understand the team's goal and you understand the pattern in use, you can create a correlation. How are we going to use this pattern to achieve that goal? That's what you need.
Yes.
And how do you get this? By learning the foundation and practicing all the design patterns out there. Because they all come from the same idea.
Yes.
Always developers trying to create more extendable, testable, simpler, maintainable solutions. And depending on the problem they have at hand, they end up at MVC. And then they end up at MVVM, MVP, and etc.
Yes.
So, depending on the frameworks you are using, depending on the problem at hand, all those things start making sense in a context. It's not an isolate decision. Which is the best design pattern? There is no design pattern that solves all the problems, no silver bullets. So, learn the foundation. Remember, your career is an infinite game. Don't play as a finite game. Well, the companies are asking MVVM, thus I'm only going to learn MVVM. 5 years ago, no one was asking MVVM.
Exactly. I was about to say that.
Maybe 2 years from now, no one's going to ask MVVM. What are you going to do then? Then you're going to have to learn the new pattern and it's going to have to go to the learning curve again and be a step behind in the market. No. Always be ready. So you don't need to get ready.
Prior to 2014, I think, nobody talked about MVVM and suddenly there it was. And exactly, we're going to have new patterns. We're going to have new trends in the market and the market reacts to trends. That's fine. But
Swift UI is going to bring some new patterns for sure.
Exactly.
It's such a different framework. People are going to come up with very good patterns around Swift UI.
Yes.
So stay tuned and notice every pattern that emerges. What is the goal of the pattern and how it achieves the goal? Understanding the foundation is going to help you navigate through any pattern easily. So don't just memorize the patterns. Learn the foundation. Then you can apply it in any team, in any context. Next question. I see different uses for view models. How can I decide the correct use for a view model? So ultimately, the correct use is the solution that solves the problem at hand and is agreed on by the team.
Yes.
That's it. There's no the correct use of a view model. There are guidelines. For example, in MVVM, a view model can have dependencies and behavior. But in MVP and MVC, a view model is just data.
Yes.
So if your team decided that view models in our team is only data.
Right.
The correct use of view models in your team is to represent only data in your view models.
Yes.
No behavior, no dependencies. If your team decides to use view models with behavior and dependencies, that's the correct use for your context. If it solves the problem and the team agrees on the definition, that's the correct use of it.
Exactly. It's the same with the naming view model and this data model that you describe. Perhaps in one team, they call it view model, and then you go to another team, they use exactly the same immutable kind of data structures that are going to be fed to the views, but they call them presentable data.
Or DTOs.
Right, or DTOs, yes. And you might say, no, that's wrong. They're called view models. But that's exactly right. These are just semantics. And sure, semantics have their place, but it's up to the team to decide, and the convention of the code base, of course, what is the rule? What is the guideline here, and how developers should name these types of objects.
And it's, as you said, it's important to have a common vocabulary as an industry. But ultimately, whatever your team uses is the vocabulary you should use. In DDD, they call this the ubiquitous language.
Right.
It's the language that your team uses. For example, if the business called users, you create a user model when you're representing that user in your system. But if everyone in the business called the users customers, you create a customer model in your system because that's the context this name is going to be used on.
Yes.
Right? Even if you learned in university to call it person and you use this name person in a meeting, no one's going to understand which person. What are you talking about? It's a customer. Oh, a customer. Yes. So you need to have this shared language with your team, with the business, with the devs, with everyone.
This is literally the foundation for communication, for good
Yes.
communication.
And if you think there is a better name, there's a conventional name like ViewModel or presentable model, and you want to use it in your team, you need to present the idea to your team and educate them towards that name so
Yes.
they start adding that name to their vocabulary. Just don't call it in the code base because you think it's the correct thing because you read it in a book. Read it in a book. Fantastic. Is it a common standard in the industry? Fantastic. Educate your team and then you change the name together
Yes.
if it makes sense.
Yes.
So there are many definitions of view models. We have a quote here from the Dependency Injection Principles, Practice, and Patterns book. The role of the view model in MVVM is different from the view model in an MVC application. With MVC, the view model is a behaviorless data object and is newed up in your application code. MVVM view models, on the other hand, are components with dependencies, and view models will be composed using dependency injection. If you have behavior in an object, like a view model with dependencies, you pass the dependencies with dependency injection, just like any other component with dependencies in your system. But in MVC, since a view model would represent just data, you don't need dependency injection because there are no dependencies, just data.
This has also to do with the semantics that we were talking before. Someone might say a view model in MVC, like there is no acronym saying VM in MVC, view model. That's it. That's correct. There is no acronym. There is no view model in the name, but the view, it's not about the name. It's about what it represents, what view model represents here. And that's just immutable data with no dependencies, right? So yeah, we don't have to make a fuss.
You don't need to add all the components in your system in your acronym.
Of course not, right?
You wouldn't be able to pronounce it, first of all.
Exactly, exactly.
So when you say MVC, MVVM, or MVP, you don't have only 3 components.
Yes.
You may have 10 different types of components. But MVC, MVVM, and MVP is just a shortcut to represent what do you want to represent in your system. They are patterns and guidelines. So when you say, I'm using MVC view models, if you know what your team means, you instantly understand what they mean.
Mm-hmm.
You don't need to explain all the architecture and draw diagrams. No, we have a language so we can communicate our intents easily. And that's it.
That's exactly right. Or in MVP, for example, the view in UIKit, it will contain at least 2 kinds of objects. The view controller, the UI view controller subclass, and the UI view.
Yes. Or in Swift UI, only 1 component. Or 2 or 3. It's up to you to decide. There are the guidelines that you can follow. And if you follow the guidelines, you'll have a very rich standard vocabulary to talk about your components, about your design, about your architecture. So you can present it in blog posts. You can go to conferences and talk to people about it. And they're going to understand what you mean. So that's it. You need to read books, join meetups, go to talks, learn the shared vocabulary in the industry. And you can build on top of it. You can create your own vocabulary, can bring new ideas to other developers, to your team. Because communication is key. Next question. Should I use only MVC if I'm using storyboards? No. You can use any pattern.
Yes.
There's nothing forcing you to use MVC with storyboards. Of course, with the storyboards, you're probably using UIKit, and UIKit comes with view controllers and views. So you kind of have by default the MVC layer there for you in the framework. But storyboard is part of the view side, and all patterns have a view. MVP, model view presenter. MVVM, model view model. So if you separate the view from your model, from your view model, and from your presenter, using storyboards or not will be just a UI detail, a VO detail they don't need to know about. So you can use storyboards with MVC, MVP, MVVM. There's no limitations there. The problem with storyboards is that you may start holding too many responsibilities.
Right.
Like layout, navigation, dependency injection, view configuration, constraints, and etc. So we recommend you to limit those responsibilities to 1, maybe 2. So we usually use storyboards for simple layouts and only for the view layout. The navigation will probably go to another component. Dependency injection will go to another component. And if you keep your models, view models, and presenters decoupled from those UI details, you can plug a storyboard in the view side. You can use code, you can refactor from code to storyboards, from storyboards to code, without affecting your models, your view models, and your presenters. Mm-hmm. It's just a detail.
Yes.
And if it's just a detail, it's easy to use, test, extend, maintain, replace, reuse, etc.
That's it.
So next question. Can an MVVM view model work with multiple views and models? Yes, you can have multiple views binded into the same view model, because the view model doesn't reference the view directly. It doesn't know about views.
Right.
It's up to the binder to decide that.
There is a difference, though, when we say multiple, from 2, let's say, views or 2 models to 10. They're both multiple, right?
Right.
So you need to balance these dependencies as well.
There are no limits, but definitely too many.
Yes, exactly. That's exactly right.
So you can plug your view model or bind it with multiple views in the binder side. But if your view models are binded to 5, 10 views, probably your view model is doing too much.
Yes.
If it can be plugged into so many views, it probably exposes a bunch of observable operations, data.
Yes.
Maybe you can break down that into many view models. That can also be decomposed and used in isolation.
So that's a terrific signal. How many callbacks are there? How many dependencies from the model side the view model might have? If there are, I don't know, like more than 1, maybe 2 maximum, then you should definitely think about breaking that.
Because the other question was, can a view model work with multiple models?
Right.
Yes, you can pass as many models as you want to the view model to translate. But is this what you want? Yes. If you're passing multiple models to this view model, maybe it does too many things. Maybe break it down instead into multiple view models.
Mm-hmm.
It's a trade-off here. So it depends. If you have to pass 3 models and plug 5 views to the same view model, it probably does too much. If you pass 2 models and it plugs to 1, 2 views, maybe it's okay. You're going to have to find this balance there of maintainability, reusability, testability. If you follow the goals, you're going to end up with a good solution. If you're creating maintainable, testable, clean view models, that's what matters.
Yes, exactly.
All right, next question. Should I test controllers in MVC, view models in MVVM, and presenters in MVP? Or should I just test everything in integration, for example, with UI tests?
Right.
Well, trade-offs, again. You can test in integration. You can test everything in integration. You can either do it with XC tests or UI tests. Mm-hmm. Actually running the application, pressing buttons, and checking the behavior. This might give you some confidence that the whole UI stack as a whole works as intended. But there are limitations and downsides to that as well. For example, when testing the whole thing as a black box in integration, you cannot easily test error or edge cases, like a database failure or a network connection failure.
You don't have the same degree of freedom.
Yeah.
You lose your freedom, basically. If you go to the higher level of testing in the testing pyramid, meaning UI tests and integration tests, opposed to isolated tests, then you lose your freedom.
But you kind of check that the whole system and integration works, which is good.
Yes.
Although it can be slow, very stateful and fragile. Like one test affects the result of the next one. You need to always clean a database, for example. So it can be very slow to run the app, press buttons, and test stuff. It can also be fragile, but it gives you some extra level of confidence that the composition works.
Right.
The application does what it's intended to. But as you said, by not testing the presenters, the controllers, or the view models in isolation, you risk missing to check those edge cases in your system as well. That can be where the bugs live.
Right.
So I think you need a mix of both. You need the majority of tests in isolation, unit tests, checking every component, controllers, presenters, view models. Then you can test all the edge cases, all the error cases, all the scenarios. And after checking all the scenarios in isolation, you need some integration tests to prove the whole composition works as well. But much less.
Yes.
Just few tests and testing what you can, probably only through the happy path.
Right.
Because if you cannot simulate reliably edge cases, you cannot test this in integration. So you usually see only the happy path in an integration UI test style.
Yes.
As a black box. So you need to mix and balance isolated tests, integration tests, because they all have their strong points and their downsides. But you need both.
I like the pyramid, I like to follow the pyramid.
It represents perfectly.
Yeah, like there's just a tiny portion at the top that has end-to-end tests for a whole application, especially UI tests, right?
Yeah.
The majority is isolated tests. Then you have some integration tests. Then, some UI tests. Because they're so expensive as well, right? Like I think we need to mention that the cost for writing and maintaining UI tests is just tremendous compared to the cost for writing and maintaining unit tests.
Yes. So you want a lot of unit tests and a few integration tests or UI tests, because you can have integration tests that don't go through the UI.
Right.
They just integrate a small portion of your application and you test only that portion in integration, which is more reliable and faster as well.
Yeah.
So you need to balance all those testing strategies because you probably need all of them. Next question. I'm changing the networking layer of the app from HTTP to WebSockets. How will this affect my UI architecture? I'm using MVVM in the UI side. So you're changing the network layer of the app. That should not affect the user interface. With the right abstractions, that should not affect the user interface.
Yes, exactly. There is a boundary between business logic or other modules, other components, and the UI. And these two should not meet, should not influence one another. So HTTP is just an infrastructure implementation. So is WebSockets.
Yeah. Just like if you're changing your database from realm to core data or core data to realm.
Exactly.
It's also an infrastructure detail.
Yes.
You want to keep the same behavior regardless of the infrastructure you're using.
But I think I can understand why there might be this idea of, okay, this sort of change from HTTP to WebSockets can influence my UI is because you have an open connection basically, right? So perhaps your UI is going to be triggered so much more often.
Right. But it's like, if you're keeping the same behavior, you just want to change exactly the mechanism, right? The delivery mechanism.
Yes.
If the behavior is the same, you shouldn't have to change anything else.
Yes.
If you have good abstractions. But now if you're leaking details of HTTP requests, like HTTP responses, etc., in your UI layer, in your business logic layer, this change is going to cascade.
Yes, exactly.
But if these WebSockets might trigger UI changes more often. Yeah, it's just going to trigger UI changes more often. That's fine. That's actually what you want. That's probably why you're going to WebSockets.
Exactly. The UI will just react to the events.
Yeah.
And that's it.
You tell the UI, render this view model, and it does it.
Yeah.
That's it. You might request it to render it more often.
Exactly. Or there might be some sort of change there where, I don't know, for example, if you did a pull to refresh when your app supported HTTP, then yes, of course, you're going to have to, maybe the new feature says we're not going to use pull to refresh anymore. The screen will update on its own, right? Yeah, like this is now this is a UI change, right?
And it should be easy to remove UI elements as well.
Right.
If you have an MVC for the pull to refresh, you just remove the MVC from the composition. Everything else should work.
That's it.
So yeah, this should be an easy change from the point of view of other modules, because they should not be affected. Or if they are affected because there are some new rules, like I want to remove the pull to refresh, they should be localized. I'm only going to remove that thing. Everything else is going to work. Should be easy. If you have good abstractions, the only work you need to do is in the delivery mechanism side, in the infrastructure. You need to implement this new network layer there.
Yes.
But nothing else should be affected. Next question. How can I learn MVC, MVVM, and MVP fast?
Right.
First of all, learning the foundation right, like getting the right foundation is more important than speed. Again, Your career is not a short sprint, right? It's not a finite goal. It's not a finite game.
Yes.
Your career is a marathon. So you need to think more about the long term than speed. But speed is important. You want to learn in an optimal way. If you can learn something in 2 days, you don't want to take a year, right? So how can you learn as fast as possible without damaging your understanding?
Yeah. Good sources and practice.
So books, courses, mentors.
Exactly. And then you just put in practice again and again and again and again. We've been repeating this so much in this podcast, but we're doing so because it's the truth. Like, there's no other way.
It's a continuous process.
Yes, exactly.
Learn, practice, execute.
Yes.
Over and over. There are many books, courses, and videos out there, but choose your sources carefully. Otherwise, you're just going to get confused.
Yes.
And ultimately, you're going to learn by practicing. You can read all the books, you can watch all the videos, you can go through all the courses. If you don't practice, you're not going to learn.
And when practicing, try as well to not only follow the conventional paradigms. For example, if you have an MVC implementation, try shifting to MVVM, try shifting to MVP, or transforming your MVP back to MVVM. Try to be in control of what's going on there and not just say, again, have a static perception of these design patterns. Right?
Yes.
No, these things should be flexible. Or another good exercise is try to create a suite of integration tests. Start with MVC as your design pattern, then move to MVVM without altering the tests, then move to MVP without altering the tests. These are very, very good exercises that are going to show, they're going to show you what you need to work on.
And at first, you have to change the tests, and that's fine.
Absolutely.
And you're going to learn, why do I have to change the test? You're going to look exactly what parts of the test you need to change. So next time, I'm going to do it differently.
Yes.
And that's how you learn. You learn by practicing. When you refactor from MVVM to MVP, you're going to look and say, it's more similar than I thought.
Exactly.
It's very, very similar. So, practice, practice, practice. And execute,
Yes.
Apply it. Teach others. And if you really, really, really want to go fast, you need guidance, mentors. If there's a senior developer that can help you in your team, that's how you're going to learn fast.
Exactly.
Take the opportunity or find someone that can help you.
Yeah, we have a lot of videos on these subjects on YouTube for free. So
Yeah.
check them out if you haven't.
With diagrams, code, everything you need to know.
And if you haven't checked the previous podcast, check them as well, because we talk about these things all the time.
Exactly. So be exposed to those ideas. Keep practicing and they're going to click. It's going to make sense. And you're going to be able to apply it at work and get the rewards. But you need to practice.
Yes.
So I think that's it for today.
Okay.
Very long episode again, but those are important design patterns. We deal with them every day almost. So we need to get used to it. So that's it. And if you want to go the next level, join us at academy.essentialdeveloper.com.
Okay. This is going to do it for this edition of the iOS Lead Essentials podcast. Leave us your feedback, your questions, your thoughts. We'll see you all next time. Bye, y'all.
See ya.